All right, so if you've done one decision tree, let me just clean up this one. All right. Uh, so you saw one decision tree can do a certain fitting job, but what's much more powerful is to have ensemble learning where you combine several different machine learning models together to improve their accuracy. So here, we're going to have a data set, which is again just going to be one of these moon-shaped things where we're trying to separate these two categories of data. All right, now we're going to classify it with an ensemble using three different kinds of decision trees, something called logistic regression, a scalar support vector machine we've talked about, and a random forest. Random forest is an ensemble of 100 decision trees. So you make 100 decision trees with random different locations for the if statements to branch, and then you combine them together. That's what this will do. Having three different kinds of machine learning models trained on the same data, but hopefully making different errors. And then you'll combine the outputs of those three to get better results. So here's the three models alone, 86% accuracy, 89 and 89. And when you combine them by just having votes, where when 2 out of 3 of them agree that then you take that, then you get up to 91%. So that is one way to improve the accuracy by combining different measures. As long as the measures are somewhat independent in their noise, the noise will tend to cancel out. However, this is a very wasteful way to combine them because remember, all these things don't put out just true or false. They put out a signal that's variable. And so you could combine the signal and include more information than just trying to pick 2 out of 3. In soft voting, they each output a probability and you average the probabilities. So I don't need to retrain the models. I just need to recombine the models. And that's what this will do. And now I get up to 92% accuracy by doing soft coding. Now, another technique is bagging, where you want to make a whole lot of different models to combine together. And so what you do is you pick a subset of the data to train it on, and you keep picking different random subsets of the data to train it on. So you get models that are different. They call that bagging. And so this is going to make a bagging classifier with 500 decision trees and then combine the output of those 500 decision trees to make a better model. And so now we're going to see the decision boundary, which there may be a problem here. All right, looks like we may have some debugging to be done here. Can't figure out what a bagging classifier is. Got an unexpected keyword argument base estimator. It looks like they have changed something in the library. So something is not working here. So that'll be something to try to fix. But anyway, a single decision tree would do this, trying to fit the data, following a sort of erratic pattern. But when you combine many of them, then you actually achieve what you want, which is sort of a smooth curve through the average of the trend. All right, and so there's another one you can do with 5 trees. Interesting, you see how many trees go there. And now we can get to AdaBoost. This is adaptive boosting, where you train the predictors sequentially. The first one tries to fit the data. The next one tries to give you an error correction for the way you missed here, and so on. So they make successive approximations. Let's see if this works. Something was wrong with that other one. They've changed something in the model, and I'll have to do research to find out what I have to change it to. They keep doing this. They change the parameters in the model so the stuff that worked in a previous version of the libraries no longer works. And it looks like there's something wrong here too. Plot decision boundary is not defined. There's plot decision boundary. It just isn't defined because this didn't run. I could probably just add that here to get through what we're doing right now. Yeah, there we are. And this is what I wanted to show you. If this is the first iteration, then the next one with a high learning rate jumps to here, and the third one jumps to here, and the fourth one goes here, and the fifth one jumps to there. This is what happens when your learning rate is too fast. So you try to predict how to improve it from where you are, and you go too far, going past the optimum, and so you do not actually improve with iterations. You instead diverge and fly off the handle. If you shrink down the learning rate, it takes smaller steps, and now you can see it takes small steps and converges to a good fit. All right. All right. And there, and that's AdaBoost, what we just did. That was adaptive boosting. And there's another one to try here with 10 cycles. You can see how it goes. With a high learning rate, it just goes crazy. And with a small learning rate, it converges. So that's an interesting one to see, ensemble learning, although there's a bug partway through. Hopefully someone can figure out what to do about that. Let me stop recording this one.